Okay, guys. In this video, we'll be treating axioms of probability. And what is probability? Probability is simply the rule of uncertainty or the likelihood of an event to occur. I believe most of us have the basic knowledge of probability. So when we say something is not certain to occur, that is probability. Take a look at a football match between Chelsea Football Club and Arsenal. You'll notice that the match, all games, you are not certain about which club would turn out to be the winner of the match. So it is a probability. It is on probability. The same thing as game. You understand? When you play game, when you play Ludo, they are all probabilities because you are not certain of who is going to emerge the winner. But I will not be deliberating much on probability, definitions of probability, types of probability. We have types, but in this video, what we just need to do is the axioms of probability. So in this video, we'll be checking out the axioms of probability. So the first axiom the first axioms of probability, which we'll be treating, is number one: a probability must not be greater than 1. A probability must not be greater than 1. It can be 0, but it must not be greater than what? It must not be greater than 1. So that is the first axiom of the probability. That is the first axiom of a probability. You must know that the probability must not be greater than, it must not be less than 0. There's nothing like probability of negative sign, you understand? And it must not be greater than 1. So if you solve a solution, if you arrive at a final answer of 1.5 in the probability question, so you should know that it is what? It is a probability. Now, what is A? A simply belongs to the member. A simply belongs to the member of an event, and an event is also a member of the sample space. You understand? The basic foundation of probability, you need to be familiar with the sample space after an experiment, sample space, and event. Most people normally confuse sample space with event. You understand? Actually, the truth is that a sample space, an event is a subset of the sample space. But don't worry, in my next video, I'll be explaining those parts to you. So let's just concentrate on this video. Axiom number 2 is the probability of x must be equals to 1. What does this mean? This simply means that when you take the probability of all the events in the sample space, you must have 1. That is when you toss a coin of 6. When you toss a die, understand? A die has six spaces. Understand? So when you take that probability each and add all of them together, you must arrive at 1. So that is that. So the number 3 part is the probability of an empty set. Probability of an empty set, and the probability of an empty set must always give you what is 0. That's axiom number 3. Axiom number 4 is probability of A complement. You understand? Probability of A complement. A complement simply means probability of an event not occurring. So probability of an event not occurring equals to 1 minus probability of what? Of an event occurring. So that is the number 4 part of the axioms of probability that we have. Now, in my next video, as well, I'll be explaining what we understand by mutually exclusive events, independent event, exhaustive event, and all type of events. We have different type of events. Knowing the definition of event and sample space, you have to know the types of events that we have as well. So in my next video, I'll be explaining the types of events that we have. So number 5 says that if A and B are mutually exclusive, then the probability of A or B, which can also be written as probability of A union B, probability of A union B is equals to probability of A plus probability of B. This condition only holds if the events are mutually exclusive. So this condition only holds if the probability are mutually exclusive. But if they are not mutually exclusive, mutually exclusive, that does not mean that they are independent. It's just if they are not mutually exclusive. We have a different way of writing that, and the formula is probability of A plus probability of B minus probability of A intersection B. Probability of A intersection B. Okay, that is that for that. So the first one, number 5, is if they are mutually exclusive. Number 6 is if they are not mutually exclusive. We also have if the events are occurring at the same time. So if the events are occurring at the same time, it simply means they are independent. You understand? They are independent. And when we say something is independent, we are talking about they can occur at the same time. So there is an intersection sign between the two of them. So if they are independent, what you do to the probability is just to multiply the two probabilities together. You just multiply the two probabilities together. So if they are independent. So that is that for that. So the last part of the axioms of probability, which you need to know, is if when you have more than one mutually exclusive event, you have to add all the probabilities together. You understand? You have to add all the probabilities together. So that is, let's say you have the probability of more than one event. You understand? More than one event. So the events are unknown. They are nth term. So let's say we have our I to be equals to 1 to nth term. So we have that to be the probability of A. Let's say probability of A. So this simply means, this simply equals the sum of n, the sum of okay, the sum of n, where I equals 1, then we have the probability of a of j. Not fully aware that I is not equals to j in this condition. So these are not, and a intersection b must not be equals to 0. So please take note of this. A intersection b must not be equals to 0. So if you want a foundation in probability to be strong, you should know these basic axioms of probability. They are very, very essential. In my next video, I'll be explaining the basic of probability, types of events, Bayes theorem, conditional probabilities, and all that. So do well to subscribe to this channel, and hope for my next video. Thank you.